Welcome back to the Deep Dive. Today we are strapping on our virtual scuba gear and descending into, well, one of the most critical topics in cloud infrastructure economics.
I think so, yeah.
It's all about optimizing your Google Cloud storage spending. And this isn't just, about finding the cheapest place to dump your files.
No, not at all. It's about figuring out way to put your data so you don't completely break the bank the moment you actually need to use it.
Right.
It is the great paradox of the digital age, really. We have this infinite appetite for keeping data driven by compliance, history, AI, you name it, but we have a very finite budget for accessing it.
So our mission today is to decode Google Cloud Storage, or GCS, and its 4 distinct classes.
Standard, nearline, cold line, and archive.
Our source material has basically given us a surgical map of this whole cost landscape, and the puzzle for you, our listener, is how to leverage this tiered system.
Right, the core challenge is simple. How do you get to maximum cloud efficiency by perfectly matching your data's access frequency to the right storage class?
It's the ultimate trade-off, isn't it?
It is. The price of instantaneous access versus the sheer cost of just keeping petabytes of data dormant. These 4 classes form a really precise cost spectrum. But success hinges entirely on understanding the commitment you're making to Google.
Okay, let's unpack this. Before we dive into what makes these tiers different, we have to start with the universal foundation.
Yeah, right.
Because when we talk about hot data versus frozen data, you just assume massive technical differences, right? But the surprising truth is that GCS has engineered this, astonishing uniformity across the board.
That's a great way to put it.
So what's the fundamental non-negotiable standard they all share?
Well, these baseline features are what allow this whole cost optimization structure to even exist. And you're correct, they are uniform. The first one is non-negotiable. Durability.
Okay.
All 4 GCS storage classes offer the same high level of durability, often cited as 11 nines. That's 99.999, well, 11 of them.
And to put that into perspective for our listener, if you store, say, 10 million objects in a bucket, that level of durability means you are statistically likely to lose only one of those objects over the course of, 10,000 years?
Precisely. It's an astronomical level of safety. It's achieved through massive redundancy across multiple physical drives, multiple availability zones.
So the key takeaway for you listening is that the class you choose, whether it's standard or all the way down to archive, has absolutely no bearing on the fundamental safety and persistence of your data.
Exactly. We are not trading resilience for savings. That's off the table.
That is such a crucial architectural decision. So since the data safety is constant, we can move to the second universal feature, which I think is maybe the most strategic element of the GCS design.
Latency.
Latency.
Yes. And this is where GCS really distinguishes itself from, the older archival models. Whether your data is standard, meant to be accessed every second, or archive, meant to be accessed maybe once a year. The latency for the first byte of that data is still measured in milliseconds.
Milliseconds. That is the game changer, isn't it?
It really is.
Historically, archiving data meant moving it to tape or some other deep storage where you accepted a minutes to hours retrieval delay. A thaw time, they called it.
A thaw time, exactly, before you could even start reading the file. Here, the data is just instantly accessible. Always.
That constant low latency across all tiers means that GCS archive data is still technically online.
Yes, and immediately available for production workloads, which means the availability service level agreements, the SLAs, they're primarily determined by the bucket's location. Is it a regional or multi-region bucket? Not by the storage class itself.
So all tiers are suitable for production because that access speed is identical.
That's it.
Okay, so if durability is constant and speed is constant, what becomes the singular differentiating factor that lets Google charge these dramatically different prices?
It is purely and exclusively cost. And that cost is structured around access frequency. The model works like this. As the required frequency of access goes down, moving from high to monthly to quarterly to yearly, the monthly storage cost plummets. But to offset that radical storage discount, the cost to retrieve or read the data, the retrieval charge, it increases dramatically.
So the retrieval penalty acts as the deterrent. That's what stops you from using the wrong tier.
It's the economic stick, yeah. And that brings us to the second primary differentiator, which is the commitment.
The minimum storage duration.
Exactly.
Yeah.
This is the mechanism that allows Google to guarantee those radically low prices in the colder tiers. They can only offer you a deep discount on storage if they know they can allocate that physical space for a guaranteed minimum time.
And if you break that guarantee, you pay up.
You pay an early deletion fee. We traverse a really clear commitment spectrum. Standard has no minimum duration.
None at all.
Nearline requires 30 days, Coldline demands 90 days, and the cheapest tier, Archive, requires a full 365-day commitment.
And this commitment is the variable that companies so often fail to track, right?
It is, and it leads to these massive, totally unexpected early deletion fees when they delete objects that, haven't lived out their term.
All right, let's start at the top of that spectrum then. Standard storage. This is the hot tier, designed for data that's active, constantly used, or required instantly and frequently.
Standard is the default for any high-performance application. If you're building, running, iterating, serving content in real time, this is where that data lives. Its whole identity is defined by frictionless access.
And the most significant characteristic that defines this tier, and frankly justifies its higher monthly storage price, is the feature of zero retrieval fees.
Yep, that's the one.
You pay for the space, you pay for the data to leave Google's network, what we call network egress, but there is no per gigabyte fee just to read the data within the cloud environment.
And that is the critical factor for scaling. I mean, imagine an e-commerce platform where a product photo is loaded 10 million times a day. If you had a fee of even like 1/10 of a cent per gigabyte retrieved, that tiny cost multiplied by millions of reads would instantly make the application unprofitable. Standard storage protects the profit margin on high-volume access.
And the second defining characteristic is the no minimum duration.
Yes.
This is so crucial for temporary, ephemeral workloads.
It provides agility. If you spin up a massive compute cluster to analyze a temporary data set, and that analysis only takes, say, 3 hours, you can delete the 100 terabytes of data immediately afterward. If you put that data into Nearline or Coldline, you'd incur that 30-day or 90-day penalty, completely negating any savings you thought you were getting.
So Standard is really the only place for short-lived data.
It is.
This is probably a good moment to get into the technical specifics of operations, because I think our audience needs to understand exactly how this cost model scales.
Sure.
The source material refers to Class A and Class B operations. What are these, and how does Standard handle them so efficiently?
Okay, this is fundamental to cloud storage billing. Class A operations are generally write operations or metadata changes.
Like uploading a file.
Exactly. Uploading new files, listing the contents of a bucket, updating metadata, or executing lifecycle changes. They're more complex and relatively expensive in all tiers because they require modifying the system's state.
And Class B.
Class B operations are read operations, simply reading the data, like a GET request. They are generally much, much cheaper individually.
So Standard is optimized because it bypasses all the retrieval charges on those read operations,
The Class B charges.
which are the ones that typically contribute the most to the bill in the colder tiers.
Exactly. Standard actually has higher base costs for Class A operations than the colder tiers, but the massive number of free Class B operations is where the savings materialize for high-throughput applications.
Any cloud application with thousands of reads per second needs Standard.
It has to have it because those continuous Class B operations remain free.
Let's cement this with some applications. Serving web content is the obvious one, right? Images, videos, static assets on a high-traffic news site.
And this includes things like logs from active monitoring systems or, as we mentioned, gaming assets.
Oh yeah, good one.
Textures and levels that have to be loaded instantly and concurrently by hundreds of thousands of users. If the texture pack for a game was stored in a colder tier, the company would literally go bankrupt from retrieval charges before the first day was over.
The hypothetical example in our notes is really clear. A social media app storing trending stories that are viewed millions of times in 24 hours.
It's the only sensible economic decision. Any storage savings you'd gain by moving that frequently accessed content to Nearline would be immediately, and I mean immediately, overwhelmed by the retrieval fees.
So Standard storage is the necessary foundation for any high-throughput, latency-sensitive, profitable digital product.
Absolutely.
But before we move on, we have to note a critical nuance here.
Okay.
While Standard has zero retrieval fees, it is not free access. The network egress fees still apply.
A vital point. Egress is the fee charged when data leaves the Google Cloud Network and travels to the user on the public internet.
And this cost is external to the stored class cost structure, but it can be a major expense.
It can. So if you're running a content delivery network, a CDN, from Standard storage, you are paying zero retrieval, sure, but you are still paying substantial egress for every single byte served to a global audience.
So the focus here is on optimization within the cloud. But we have to acknowledge that egress can sometimes just dominate the total bill.
It can, even in the free access tier.
Now we move one step down the cost spectrum to nearline storage, the cool tier. This is where the true cost optimization journey begins, and where we accept the first major trade-offs.
Nearline is the perfect inflection point for data that is still readily accessible, but it's only expected to be accessed about once per month.
Think of it as data that's important enough to keep warm, but maybe not important enough to keep piping hot.
That's a good way to look at it.
The defining trade-offs start here. The storage cost is significantly reduced compared to standard,
It is.
which is great for long-term retention of large volumes, but it comes with two fundamental conditions.
The first is the introduction of the retrieval cost. This is a per gigabyte retrieval fee. It's categorized as a low cost, but it fundamentally shifts the economics. You are now paying to look at your own data.
And if you access it too frequently, you just negate your storage savings.
You do.
Yeah.
And the second condition is the commitment, the 30-day minimum storage duration.
This is where users can get burned if they're not tracking the data's lifespan.
That 30-day term is non-negotiable.
Yeah.
If you upload 5 terabytes of data to Nearline on day 1, thinking you're going to save money, and then delete it on day 15 because the project finished early,
Yeah.
you are immediately billed an early deletion charge that's proportional to the remaining 15 days of the term.
So the rule, therefore, has to be, if your data is likely to be deleted in less than a month, just keep it in standard. But if you're confident it will live for more than a month and will only be accessed rarely, then you can move it to Nearline.
That is the selection logic in a nutshell. Nearline excels in applications that adhere to predictable, low-frequency access patterns. A perfect example is monthly reporting.
Like financial data, sales reports, compliance filing.
Things you access at the end of the fiscal period.
Exactly.
And backup and disaster recovery, Docker Nearline is often cited as the ideal target for primary backup copies.
Right. You need backups to exist, but in an optimized DR scenario, you hope to only access those files in the event of a production failure.
Which is a rare event, hopefully.
A very rare event. So the low storage cost outweighs the small retrieval penalty you'd incur during that emergency restore process.
Let's elaborate on the insurance company's scenario from our notes. They store current policy photos. Once the policy is written, the photo is rarely viewed, but if a claim is filed, they need that visual proof instantly. This is a textbook Nearline use case. It's because the access is high value but very low frequency. They might have petabytes of this policy data, and only, 0.1% of it ever generates a claim.
So they save immense amounts on monthly storage costs.
Immense. And when a claim does happen, the milliseconds fast retrieval ensures the claims adjuster gets the file instantly, and that small retrieval fee is easily absorbed as a cost of doing business.
It's a perfect balance of cost and operational readiness.
It is.
And this is the first place where Object Lifecycle Management, or OLM, becomes strategically essential.
Oh, absolutely.
You don't want engineers manually moving old backups or policy photos. That's just not going to happen.
No, it's not scalable. OLM is the autopilot for cost optimization. You just set a policy. If an object in the standard bucket has not been read or written to for 30 days, transition it to Nearline.
And it just happens.
It just happens. This automates the enforcement of your expected access pattern, ensuring that data naturally flows to the cheaper tier as it cools off. Without OLM, these savings are, frankly, impossible to realize at scale.
All right, pushing further down the spectrum, we hit cold line storage. If Nearline was designed for monthly access, cold line is truly cold.
Yes, it's targeting data that is accessed only once per quarter.
This tier is where the savings become, really substantial. And it's often driven by massive data volume requirements.
We're optimized here for long-term retention, where the dormancy period is assumed to be significant, at least 3 months.
We have to highlight the deep cost savings. It is substantially cheaper per gigabyte than Nearline.
It is. For a company managing hundreds of petabytes, that difference in the per gigabyte monthly price is measured in millions of dollars annually.
The trade-off, however, escalates significantly.
It does. The retrieval fee is now categorized as a medium cost, so noticeably more expensive than Nearline. This increased penalty is a very explicit economic signal.
It's basically Google saying, do not access this data frequently.
Exactly. If your access logs show you are touching a cold line bucket every month, you are actively losing money compared to just keeping that data in Nearline.
And the minimum commitment doubles again.
90 days, a full quarter-year commitment.
The penalty for early deletion must be pretty significant here.
It is. If you upload data to Coldline and realize after, say, 50 days it was a mistake and you delete it, you are instantly charged for the remaining 40 days. The GCS model is just built on the certainty of that 90-day retention period.
Let's discuss the economics of that policy for a minute. Why 90 days? Why does the provider demand that commitment?
It relates directly to infrastructure utilization. When data is committed to Coldline, it is placed on infrastructure that's optimized for extremely low power consumption and high density.
Okay.
Google's cost model for offering that ultra-cheap storage price is predicated on the idea that they can count on that data just sitting there inertly for 90 days, which maximizes their resource efficiency.
So if you delete it early, they haven't recouped the operational cost of allocating and initializing that space for the long term.
That's it. So the early deletion fee isn't just punitive, it's functionally a necessary cost recovery mechanism to stabilize the low storage price for everyone else in the system.
That makes sense. It reinforces the expectation that Coldline is for data with a clear long-term life cycle.
Precisely.
In terms of real-world applications, this makes perfect sense for strict regulatory compliance.
Oh, yeah.
Things like Sarbanes-Oxley or hyper-regulated data that has to be kept for years. You anticipate only an annual or maybe a quarterly audit, if at all.
Legacy media is another great fit. Imagine a large media company's archives of raw, unedited video footage.
Which is huge.
It's massive. It's too large and expensive for standard, but a producer might need to pull a specific sequence for, an anniversary project or a retrospective documentary every few months. Coldline keeps it accessible and affordable.
The research lab scenario is compelling because it involves truly enormous data volumes.
It does.
A lab stores petabytes of genomic sequences from completed studies. They might reference these sequences once a quarter for a comparative analysis.
When you are dealing with petabytes, even the small difference between Nearline and Coldline storage prices adds up to astronomical savings. The sheer volume forces the use of Coldline. The cost of storing 100 petabytes in Coldline far, far outweighs the very small quarterly retrieval fee they might incur when a few scientists pull some reference samples.
The scale dictates the tier.
The scale dictates the tier.
We have arrived at the far end of the cost spectrum. Archive storage. The frozen tier.
The deep freeze.
This is the ultimate tier for data that you must retain, but which you realistically expect to access only once per year, if that.
This is the tier of true long-term compliance and preservation. The storage cost is the lowest possible cost. Our sources place it around, a tenth or 2/10 of a cent per gigabyte per month? It's incredibly cheap.
And that ultra-low price is coupled with the maximum commitment.
The 365-day minimum storage duration. You are making a full-year contract with your data.
If you violate that commitment even slightly, say, you delete the data after 300 days.
You pay the storage cost for the remaining 65 days immediately. This is the financial gatekeeper for accessing that rock-bottom storage price.
But the real deterrent here is the retrieval cost. It is categorized as a high cost, and our sources note that the cost to read the data can often exceed the cost of storing it for a full year.
It can, yeah.
How is that even possible?
It's designed to be a crisis button. If you store 1 terabyte of data for, say, $1 a month in archive and you retrieve it once, that retrieval fee might cost you $15 or $20.
Ah.
You have effectively paid for 15 to 20 months of storage just to read the data one time. This ensures that you only initiate a retrieval job under extreme necessary circumstances like a federal subpoena or a major forensic investigation.
I have to ask the critical question, though. If the retrieval cost is so prohibitive, why not just use cheaper, offline physical methods?
Yeah.
What is the strategic advantage that justifies this high penalty?
The strategic advantage is the instant access. This is the single most differentiating feature of GCS, and we should repeat it. Archive data is still available in milliseconds.
Let's dedicate a serious amount of time to this. How does GCS Archive compare to competitive archival storage services, which might be similarly priced on the storage side?
The difference is operational time. Traditional archival tiers offered by competitors, like AWS Glacier, for instance, often require you to initiate a restoration job, a thaw job.
Yeah.
And that can take anywhere from several minutes to several hours before the data is even accessible. This makes those tiers completely unsuitable for any scenario requiring a rapid response.
Which means those competitors' archival tiers are essentially off-limits for real-time compliance or active legal discovery.
Exactly. GCS archive data, however, can be accessed instantly. You pay the financial premium for the retrieval, sure, but you gain a massive operational advantage: immediate millisecond access to truly frozen data.
So a company can architect a legal discovery pipeline that dips into archive data,
Costly.
but without triggering an hours-long data recovery delay.
Right. This capability makes GCS Archive viable for emergency business continuity or real-time forensic requirements where competitor offerings just aren't.
So the choice for GCS users is purely an economic one. It's, do you pay the low storage cost plus the high retrieval cost for millisecond access, or do you move the data to a warmer tier?
You are never choosing based on how long you can afford to wait.
The millisecond latency removes the operational risk associated with archiving.
And the only remaining risk is the financial risk of accessing it too frequently.
The real-world examples really highlight this extreme cost tolerance. Legal discovery, for one.
Yep. Emails and documents kept for 10 years just in case of a lawsuit. You hope you never need them, but if a court mandates them, you need them now.
And massive security logs.
Raw logs kept for years to satisfy long-term forensic requirements. You may need to examine a suspicious connection from 4 years ago. You need instant access to that log file to perform the analysis, and the archive cost structure makes storing all those inert logs affordable in the meantime.
The bank storing 7 years of ATM security camera feeds is the perfect encapsulation of this.
It is.
They have a massive inert data set required by federal law, and they expect to never view 99.9% of the footage.
Archive provides the lowest storage footprint possible for that huge, just-in-case regulatory burden. And the high retrieval fee ensures that only genuine high-stakes requirements trigger the access. Without Archive, the scale of data retention required by modern law would simply be financially prohibitive for large institutions. #tag 6. Practical selection logic and cost analysis.
Okay, now that we've established the full spectrum, let's bring this down to brass tacks.
All right.
How do we correctly segment data within a single organization? We need to internalize the logic that any smart enterprise will use all 4 tiers concurrently.
This is the data lifecycle in action. Data is born hot and useful, and as it ages or loses relevance, it automatically cools off and moves to a cheaper tier.
Let's walk through the e-commerce platform example from our notes. This really shows that value decaying over time.
Okay, so starting with standard, this is the active layer.
Product images, current shopping cart states, the active code base like CSS and JavaScript files.
Right. Access is continuous, sometimes thousands of reads per second. 0 retrieval fees are mandatory for profitability here.
Then we move to Nearline, the monthly access tier.
This would be user invoices and transaction histories from the last 6 months. They're necessary for monthly customer service inquiries, returns processing, or the finance department's end-of-month reconciliation.
Access is sporadic, but required instantly, making that 30-day minimum worthwhile.
Absolutely.
So where do we draw the line for cold line?
Cold line is for the quarterly checkup data. Think detailed application logs and database snapshots from, say, 6 to 18 months ago.
Right. You need them for that quarterly security audit, or maybe a performance tuning exercise every few months, but not for daily customer service.
Exactly. The 90-day commitment is easily met.
And then the regulatory hammer, Archive.
Archive is for the transaction records older than 2 years, kept strictly for the mandated 7-year tax audit period. The data is completely inert, kept only for compliance.
And we are relying entirely on OLM to move this data automatically at the 365-day mark.
You have to avoid that crushing early dilution fee.
Let's shift gears to a high-tech scenario, an AML training workflow. The data files here are immense, making cost optimization even more critical.
In ML, data freshness and frequency define the tier. The standard tier is reserved only for the active data set.
That specific 100 terabyte slice of data currently being actively read and written into the GPU training clusters.
Yep. Reads are happening hundreds of times per second. No other tier will work.
The training run finishes. The raw data set is now slightly less active.
That moves to Nearline. These are large, raw data sets that have been processed and used, but you might reprocess them next month with a slight modification or use them to fine-tune a newer model.
So it's accessed frequently enough that cold line's retrieval penalties would hurt.
But not frequently enough to justify standard monthly cost. That's the sweet spot.
And the source of truth data, the original raw input from 2 years ago.
That goes straight to Archive. It's kept only for reproducibility requirements. In academic or highly regulated ML environments, you have to be able to prove your results are reproducible years later.
And that original input data set is the ultimate source of truth.
It is. You need it preserved, even if you never touch it again. The moment you do retrieve it to prove reproducibility, you pay that archive premium, but it avoids the storage expense for 23 months.
This just highlights the absolute necessity of automation. If you rely on humans to enforce these rules, you will fail.
You will, 100%.
We keep mentioning OLM Object Lifecycle Management. Explain again how it maintains this cost optimization across the 4 tiers without any human intervention.
OLM is the programmatic enforcement layer. You define policy rules right within GCS. If an object is 90 days old, transition it from standard to nearline. Or if an object hits its 365th day, transition it from cold line to archive.
And the cloud just handles it.
The cloud infrastructure handles the move seamlessly, ensuring your data is constantly migrating to the cheapest possible tier as its utility decays. It prevents unnecessary spending, and it prevents accidental breaches of those minimum duration commitments.
Okay, let's get into the hard numbers. This segment, Scenario Deep Dive 1, this is the proof of the entire thesis. We have to be able to prove that chasing the cheapest monthly storage price can be a trap.
Let's do it. We have 10 terabytes of data.
And we'll use some typical pricing models. Option 1, store 10 terabytes in standard. The storage cost is, let's say, $200 per month.
Okay. And the retrieval cost is 0, so the total monthly cost is $200. Simple.
Option 2, store that same 10 terabytes in nearline. Storage cost is $100 per month, significantly cheaper.
But the retrieval fee is, say, 1 cent per gigabyte.
Here is the crucial operational variable. You need to read all 10 terabytes of that data twice this month. Which class is actually cheaper?
Okay, let's calculate the nearline cost slowly. We have the $100 base storage cost. Now for the retrieval cost.
We access 10 terabytes twice.
So that's 20 terabytes of total access volume. We have to convert that to gigabytes, which is 20,000 gigabytes.
And the retrieval cost is 1 cent per gigabyte.
So 20,000 megabytes multiplied by $0.01 per gigabyte equals a retrieval cost of exactly $200.
So the total cost for nearline this month is $100 for storage plus $200 for retrieval.
For a total of $300.
The conclusion is undeniable. For this access frequency, twice a month standard is the clear winner at $200 compared to nearline's $300.
The storage savings were completely wiped out and then exceeded by the retrieval penalties.
This proves you absolutely cannot just chase the cheapest storage price. If you anticipate accessing your data more than once per month, you risk paying more overall by using the cooler tier.
And we can take this even further. If we were dealing with cold line for that same 10 terabytes, which typically has a medium retrieval cost of maybe 2 cents per gigabyte,
Right?
that same 20,000 gigabytes of access would cost $400 in retrieval fees alone. The total monthly bill would probably be around $500 easily. It just shows the exponential cost increase as you move into the quarter tiers.
You have to analyze your access logs.
Yeah.
You have to. A small mistake in data classification can lead to a spectacular cost wipeout.
And we must always integrate the reality of egress into this. Even if we calculate standard as $200 for storage and retrieval, if half of that 10 terabytes is leaving the Google network, the egress fees could add another $100 to the standard bucket bill. The final calculation is always storage plus retrieval plus egress.
Let's shift to our scenario deep dive 2. Early deletion logic. This addresses the commitment policy, which is often emotionally difficult for companies to accept.
It is.
We upload 1 terabyte of critical data to Coldline with its 90-day minimum, but a week later, we find out the data is corrupted. We delete it after only 7 days.
This is an unfortunately common operational reality. Because the 90-day commitment was violated, the user will be immediately charged for the remaining 83 days of the term.
Even though the data is gone.
Even though the data is gone, the cost is incurred.
But isn't that punitive? I mean, the data was bad. It shouldn't have been stored.
It feels punitive, but it is necessary for the cloud economic model to function. As we discussed, the infrastructure cost model for Coldline is based on that high-density allocation, maximizing efficiency over a quarter-year period.
The cheap price is an annualized rate, basically.
It is. If you delete early, Google hasn't recovered the cost of setting aside that capacity for you. So the commitment policy ensures that customers are honest about the lifespan of their data before they choose the discounted tier.
If you have data that is experimental, volatile, or temporary,
Yeah.
you have to accept the higher storage price of standard.
You have to, because the agility of rapid deletion is worth more than the Coldline discount in that case. The early deletion fee is the financial mechanism that enforces disciplined data management. ###7. Conclusion and final thought.
We've completed our deep dive through the GCS spectrum. The key insight is now, I think, solidified. The decision between standard, nearline, cold line, and archive is purely an economic calculation of storage cost versus access cost.
And this entire sophisticated model is enabled by that one revolutionary engineering decision: the universal millisecond latency across all 4 tiers.
Since the data is always fast,
So the decision is never operational, it is always fiscal.
and since managing this complexity manually is, well, impossible at scale, the reliance on automation is total. We need to reiterate the critical importance of Object Lifecycle Management, or OLM.
Utilizing OLM is mandatory for achieving long-term cost optimization. You should define policies that transition data automatically from the hot tiers to the cold tiers as its access frequency naturally decays.
Set it, forget it, and let the cloud infrastructure drive your data toward the lowest possible storage cost over time.
OLM ensures agility, cost-effectiveness, and compliance without requiring constant manual intervention from highly paid engineers. It's the engine that monetizes the data lifecycle.
But before we wrap up, let's take this discussion one step further. We've covered the use cases, legal discovery, 7 years of ATM footage, regulatory compliance.
All of which demand data retention for 5, 7, 10, sometimes dozens of years.
We are talking about massive, inert data sets that must be preserved.
And this leads us to our final provocative thought for you, our listener.
What does the necessity and the sheer existence of the archive storage class, priced at 1/10 of a cent per gigabyte, reveal about the direction of enterprise infrastructure?
Is the economic imperative to provide ultra-cheap, long-term archival storage signaling that we have crossed a fundamental threshold?
A threshold where compliance, legal requirements, and regulatory mandates are now generating more inert data than the entire volume of active data we use every single day.
Think about the staggering volume of digital history we are now legally and societally mandated to preserve. If the market dictates that the cost of storing a terabyte for a year must be kept near $10, how long before technological and regulatory pressure drives that price even lower?
The sheer volume of must-keep, never-access data is fundamentally shaping the economics of the cloud.
It's pushing providers to perpetually invent cheaper ways to house our past.
It's a fascinating look at how legal requirements ultimately define the economic floor of storage pricing, something to mull over as you segment your next petabyte. Thank you for joining us on The Deep Dive.
Dive safely.